welcome. Today we're going to be looking at angles, arc lengths, and trigonometric functions as part of the additional topics in math, which is mainly about geometry and trigonometry. We're going to be looking at 5 questions here. As always, we're going to explain them and look at the intricacies of this topic to help you ace the SAT math portion. If you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get started on our first question. Here it is. Semicircle shown above has the center at O. The second of the circle by angle at M has area A, 6.25, and the radius of the semicircle is 2.5. What is the radian measure of the angle LON shown by A in the figure? All right, let's see how we're going to approach this. Well, the area of the semicircle is 1/2. Actually, let's find the area of the whole circle. So it's going to be pi times 2 squared, which is going to be 6. That area, we have 6.25 at this area. 6.25 over 19.63 is 0.318. So it is 0.318 of the area of the whole circle. So it is 0.318 of the angle, which is 0.318 of the 360 degrees. Without asking for a radian, 180 degrees is pi radians. So 360 degrees is 2 pi radians. So we have 0.318 of 2 pi of 2 pi. 0.318 of 2 pi is just the 2 radians. So the NOM right here is going to be 2 radians because the area of its sector is going to be 0.318 of the entire area, right? So that NOM is going to be 2 radians. So that means that LON is going to be the total number of radians in the semicircle, 180 degrees, pi radians, pi minus 2, and that is our answer right there, pi over 2. And we can move on to the next question. All right, here it is. And it says the circle shown at left has a center at point O. The line segment MN is diameter. Measured acute angle LOM is 0.6 radians. The shaded sector by acute angle LON has area 6. What is the radius R of the circle? Well, this is 180 degrees. Diameter. The M, the visible part is 180 degrees. Pi radians, which means that LON is pi minus 0.6 radians, or 2.541 radians. Now it has an area 6, so we divide that by the 2.514, and each radian has area each radian in a sector is going to have area 2.36. There are 2 pi radians in a circle, so the area of this total is going to be 14.8, which is going to be pi r squared. So we divide by pi, we get 4.72, and we take the square root of that, right? And our actual values end up being 2.17. That's not what they're asking us for. They're asking us for this thing expressed as a actual number, like a square root. So how do we do that? Well, we retrace our steps. We look at what we've done, right? We did pi minus 0.6, pi minus 0.6 as the amount of radians. We took the total area, which is 6, divided it by that, right? That's the area per radian. Multiply this by 2 pi. So we multiplied that by 2 pi and got 12 pi for the area of the whole circle. Then that's pi r squared, so we divided by pi, and then we take the square root. And let's see that looks like answer choice D, and that's our answer. Let's keep going. Next question, here it is. In the figure at left, point C is the center of the circle. Angle BCD has measured pi over 2 radians, and an arc BFD has a length of 10 pi inches. What is the length of diameter AD? Well, pi over 2 radians, and there are 2 pi radians in the whole circle, so pi over 2 is going to be a fourth of that. So since its arc has 10 pi inches, that's going to be a fourth of the circumference. So a fourth of the circumference is 10 pi inches, so the whole circumference is 40 pi inches. Which means that the length of the diameter, which is the circumference over pi, is going to be 40 inches, right there. So our length of the diameter is 40 inches, and we can move on to the next question. Here it is. In the figure at left, point O is the center of the circle, and points L, M, N, and P lie on the circle. Diameter LN has a length of 60, and LPM has a length of 42. This has a length of 42, this length of 60. What is the value in radians of X, which represents the central angle LOM? Well, since 60 is the diameter, then the circumference is 60 pi, which is 188.5. Out of that, 42 over 188.5 is going to be 0.222 of the circumference of 2 pi radians. The 0.222 of 2 pi is going to be equivalent to 1.4 radians. So that's our answer, 1.4. We can move on to the next question. Here it is. The sector of a circle shown at left has central angle NOP with a measure of 2.1 radians. The original circle has a diameter of 8, and we're asked for the area of the sector. Well, since the original diameter is 8, the radius is 4, so the area is going to be pi r squared, or 16 pi. That's going to be 16 pi for 2 pi radians, which means that for every radian, it's going to be 8. So 8 per radian. And we have 2.1 radians, so we do 2.1 times 8, and we get that the area is going to be 16.8. 16.8 is our answer, and we can move on. That is it for this topic, angles, arc lengths, and trigonometric functions. As you can see, the main idea here is just to manipulate the circle. We used two well-known theorems, which is that the angle measure out of 2 pi is going to be the area of the sector over the total area, and the angle measure over 2 pi is also going to equal the arc length over the circumference. But essentially, we're just using that proportion. That's all really it is to this, and if you can apply that, this will be a breeze. I'll see you next time.